To online classes of mathematics for class 9. In this video we are going to study the chapter number 4, which is the linear equations in two variable of NCERT textbook, and we'll try to cover the remaining question of exercise 4.3 and we'll complete the exercise 4.4. okay, this is our session number 4 for this particular chapter, and we'll try to finish the chapter in this session only. Okay, myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The linear equation two variables divided into total 5 subtopics, out of which we have already covered the first 3 in the previous ones, and we have covered some of the question based on the graph of the linear equation. Okay, we will complete the remaining question of exercise 4.3 first, then we will start the equation of line parallel to x and y axis, that is exercise 4.4. okay, so let's start. From exercise 4.3 we had already covered the first 5 questions, so now today we are going to start with the question number 6. Question is, if work done by a body on application of a constant force is directly proportional to the distance traveled by the body. Okay, so in physics you have studied about the work done, which says the work done by a body on application of a constant force is directly proportional to the distance traveled by the body. So we have to express this in the form of an equation in two variable and draw the graph of the same by taking constant force as 5 units. So we are given as constant force here is 5 unit. Also read from the graph the work done when the distance traveled by the body is 2 unit and 0 unit. Okay, so first you have to represent this statement in the form of a linear equation in two variable. Okay, let's start. This is answer number 6. Question says the work done on the application of a constant force is directly proportional to the distance traveled by the body. So in your physics portion you must have studied that work done on application of a body is equals to the force applied into distance traveled. This is something you have studied in your physics portion. Okay, which means this work done W is equals to the F into D. So this is the equation representing the work done by a body on the application of a constant force. So in this equation we are given, in this question we are given that let's distance travel by the body, we are taking it as x units. Okay, and work done by the body as y units, and we are given that force applied here is, or the constant force here is constant for here is 5 units. Therefore our equation will be, so we'll insert these values in this equation. Okay, so we have work done, which is we have taken as y units, so y will be equals to the f here is 5, and distance traveled is we have taken as x. So that's our linear equation in two variables are y and x here. Okay, and it involves a equality sign. So these are a linear equation in two variable in which representing the work done by a body on application of a constant force. Okay, now we have to plot this on the graph paper. So what we're going to do first is we'll find its certain solutions. So let's take let's take x equals to 0, then the y will be y equals to 5. At the place of x we'll write 0, so 5 into 0 is again 0, so the result is 0, and y is also 0. So we'll write this in the form of a table here. Here for x and y. Okay, we'll start with the solution. First one is 0 and 0. Let's take another one. Let x equals to, let's take now x equals to 1. So this will be then y will be equals to, we have 5 at the place of x, will write now 1. So y will be equals to 5 into 1 is 5. So the solution is, on taking x1 we are getting y equals to 5. Okay, now let's take a negative value. Let x equals to -1. Then we have this y will be equals to 5, and at the place of this x will write now -1. So this will be y equals to 5 into -1 will be -5. That means on taking x equals to -1 we are getting 5 equals to, so y equals to -5. So these are the three solutions of this equation. Okay, xy 0 0, x1 y 5, and x -1, and then y -5. So we have to plot this point on the graph paper now. Okay, where I've already drawn the axis here. So let's mark the points now. The first point that we have is x0 and y0. So that means that point will be at the exactly at the origin. Okay, so that's our first point. Second one is x1 and y5. That means we'll start from the origin, x1 here and y5. That means you have to move in the upward direction. So that point will be here. This is x1 and y5, and this one was 0 and 0. And the third point we have x -1 and y is -5. So x -1 is here, y -5 will be in the downward side. So that's our point here, x -1 and y is -5. So we got the 3 points. Now we have to draw a line for joining these points. Okay, so how are we gonna do that? By taking scale, put the scale on connect all these 3 points like this, and we'll put the arrow at the both end. That means this line is continuous in both the direction, and we will write the equation of graph on this line, which is y equals to 5x. So that's the solution of this question. We have represented this equation. This is the general form in the physics portion that you have studied, out of which we have reached this equation into variable, and then we have find its 3 solutions, and we have represented on the graph paper. Now you are further asked 2 more points. First is also read from the graph when the work done by when the distance traveled by the body is 2 unit and 0 unit. So let's calculate that. Part 1, you're asked when the distance traveled is 2 unit. When the distance traveled is 2 units, we are asked to find work done. Work done is given by y equals to 5x. So at the place of x we'll write 2. So y will be equals to 5 into 2 is equals to 10. So work done will be equals to 10 units. Okay, second part, we are given that when the distance traveled is 0 unit. Okay, when the distance traveled by the body is 0 unit. When the distance traveled is 0 units. Right here, then work done is, similarly then the work done is, so we'll write the equation y equals to 5, at the place of x we'll write 0. So 5 into 0 will result into 0 units. So if the distance traveled is 0 unit, that means work done is also 0 units. So that's the solution of the question number 6 of exercise 4.3. Now moving to the next one, we have 2 girls named Yamini and Fatima. These are the 2 students of class 9th of a school. Together contributed 100 rupees toward the Prime Minister's Relief Fund. Okay, Prime Minister Relief Fund, like we have in the present situation in this coronavirus pandemic situation. Indian government have announced on another fund where people can donate, which is the PM Cares. Okay, so we already had this one more fund which is called Prime Minister's Relief Fund. Okay, so the two students Yamini and the Fatima have contributed 100 rupees to the Prime Minister Relief Fund to help the earthquake victim. Okay, write a linear equation which satisfy the data, and you may take the contribution as x and the y, and we have to draw the graph of the same. Okay, so let's start. This is answer number 7. Let the contribution made by Yamini is equals to rupees x, and let the contribution made by Fatima is equals to rupees y, and the total amount contributed is is 100 rupees as given in the question here, that collectively they have contributed 100 rupees together. Okay, so we have taken the contribution made by Yamini as x rupees, and contribution made by the Fatima as y rupees, and the total amount contributed is 100 rupees. Okay, so the equation will be, therefore linear equation will be, the equation will be the contribution made by Yamini plus contribution made by Fatima is equals to 100 rupees. So that's a linear equation in two variable. Okay, that's what we are asked to write. So we are asked to write a linear equation on which satisfy the data. So the contribution made by Yamini and the Fatima is equals to the 100 rupees. Okay, so now we have to represent this data on the graph paper. Okay, let's find its few solution, and we will represent those points on the graph paper. So first let's take, let x equals to 0, then at the place of x we'll write 0 plus y equals to 100, and this 0 will be eliminated, so we got y equals to 100. Okay, so we'll write this solution in the tabular form. So the first one is, on taking x 0, y is 100. Okay, okay, next let's take, let now y equal to 0, then at the place of y we'll write 0, that this will be x plus 0 equals to 100, or the 0 will be eliminated, so we get x equals to 100. So x is 100 and y is 0. Okay, now let's start one more solution. Let x equals to 50, then we have the equation x plus 5, that means 50 plus y equals to 100, or from here y will be equals to 100. This plus 50 will shift it to right hand side and it will become minus 50. So y will be equals to 100 minus 50 is again 50. So on taking x equals to 50, we are getting y equals to 50. So these are the three solutions of this equation. X 0, then y is 100. When x is 100, y is 0. Then, and when the x is 50, y is also 50. So we got the three solutions. I will represent these on this graph paper. So first point is, when x is 0, y is 100. So when x is 0, y is 100. That means we have to extend this graph. Let's take these point as okay. I will take them at the interval of 20. This is 20, 40, 60, 80, 100 and 120. Okay, similarly on downward side, minus 20, minus 40, minus 60, minus 80, minus 100 and minus 120 and minus 140. Similarly on this axis. Okay, let's take this as minus 20, 40, 60, 80, 100, 120 and 140. Or similarly on this side, minus 20, minus 40, minus 60, minus 80, minus 100, minus 120, minus 140 and so on. Okay, so the first point that we have here is x0 and y100. that means when x is 0, y100 is here. Then we have x100, y0. When we have x100, y is 0, that means that point will be here. And the third point is x50 and y50. So that point will be between x50 will be between 40 and 60. Similarly, that point will be between here. So the cross section of this point will be here. So this one was x0, y100. This is x50, y50, and this one is x100, y0. Okay, now what we have to do is we have to join this point with the scale. Like this, and we'll put the arrows on the both end to represent that these lines are this line is continuous in both the direction, and we'll write the equation of the graph over it. So that's the solution of the question number 7. Okay, we have found first represented data in the equation in two variable, then we found its 3 solution, and we represented those solutions on the graph paper. Okay, now moving to the last question of this exercise, which is a very, very important question. Okay, this question has come in your exam many times. Okay, question is, in countries like USA and Canada, in USA and Canada temperature is measured in Fahrenheit, whereas in countries like India it is measured in Celsius. Okay, like you must have seen in the news reporting and the newspaper that today's temperature is this much degree Celsius and this much degree Celsius. Okay, because in India we measure the temperature in degree Celsius, while in some countries like US and Canada they measure the temperature in the Fahrenheit. Okay, so we are given here is a linear equation that converts Fahrenheit to Celsius. So this is a standard equation or the original equation, which the help of which you can convert the temperature from Celsius to Fahrenheit, which is F equals to 9/5 into C plus 32. F here is the Fahrenheit reading and C here is the degree Celsius reading. Okay, this is the conversion equation. So you are asked, first point is draw the graph of the linear equation above using Celsius for x-axis and Fahrenheit for y-axis. So that means we have to find the solution of this linear equation and we have to represent it on the graph taking Celsius on x-axis and Fahrenheit on the y-axis. Okay, so we'll start with the finding the solution of this equation. The equation that we have here is, let's first write the equation. We have F equals to 9/5 into C plus 32. So this is the original equation which is used for the conversion of temperature from degree Celsius to Fahrenheit. Okay, so let's find its few solution. Let the Celsius temperature is equals to 0. Okay, then Fahrenheit temperature will be F equals to 9/5. At the place of Celsius we'll write 0 plus 32. So this F will be, because it is multiplied to 0, so this whole term will become 0. So we will get 0 plus 32, or hence F is equals to 32. So the first solution of this equation is, let's write it here, x, not x, we'll write the Celsius here and Fahrenheit here, because we have to take Celsius for x-axis. Okay, this is mainly x and this is y. Okay, so on taking Celsius as 0, we are getting Fahrenheit temperature as 32. Okay, now let's take let Celsius temperature as 10 degree. Then the equation will be F equals to 9 by 5. At the place of C will write 10 plus 32. Okay, and when you solve it, this 5 will be cancelled by this 10 and will result into 2 here. Okay, so this 2 into 9 is 18 plus 32. So F will be equals to 32 plus 18 is 50. So at C10, F is 50 degrees Celsius. Okay, F is 50 degree Fahrenheit, not degree Celsius. Let's choose another value. Let's take that C equals to minus 40. If we take C equals to minus 40, which means F will be equals to 9 by 5, and at the place of C will write minus 40 plus 32. This 5 will give us 8 here. Okay, so this 8 into 9 will be minus 72 plus 32. This F will result into minus 72 plus 32 will be minus 40. So on taking C as minus 40, we are getting F also as minus 40. So we got the three solutions of this equation. First one is C0 F32, C10 F50, and C minus 40, and F is also minus 40. Now we will represent these points on the graph paper. Okay, so I have drawn the axes here. First point is C is 0 and F is 32. On this axis you can see this x-axis representing the Celsius and a y-axis representing the Fahrenheit. Okay, so first is C0 F32. C0 will be here, F32 will be somewhere here. Okay, next is C10 F50. C is 10 and F50 will be here. Next is C40 and y is minus 40. That means that will be here. Let's write its coordinate. This is minus 40 and minus 40. This one is x0 y 32 and this one is c0 y 50. Now we have to join this point to complete the graph. With the help of scale like this. Okay, and I'll put the arrows on the both end and you have to write the equation over it, which is F equals to 9 by 5 into C plus 32. Okay, so that's the solution of the first part of this question. Draw the graph of the linear equation with using Celsius for x-axis and Fahrenheit for y-axis. Okay, next we have, if the temperature is 30 degrees Celsius, what is the temperature in Fahrenheit? That means C value for the degree Celsius given, you have to find the corresponding value for Fahrenheit. Okay, so let's do this. Part second, it says if temperature is 30 degrees Celsius at 30 degrees Celsius, the temperature in Fahrenheit will be F equals to 9 by 5. At the place of C will write 30 plus 32 in the same equation. So this 5 will give us 6 here. The 6 into 9 will be 54 plus 32. Okay, and we have to add these two. 54 plus 32 will be 86. Okay, so answer of the first part is 86. Next one we have, if the temperature is 95 degree Fahrenheit, what is the temperature in Celsius? So now we are given at 95 degree Fahrenheit, Celsius temperature will be, so we have the equation F equals to 9 by 5 into C plus 32, and this Fahrenheit reading is given, which is 95, equals to 9 by 5 into C plus 32. So on shifting this 32 onto the left hand side will be 95 minus 32 equals to 9 by 5 into C, or this 95 minus 32 will result into 63. Okay, 5 minus 2 is 3 and 9 minus 3 is 6, equals to 9 by 5 into C, or this C will be, this 62 will be multiplied by this 5 and 9 will come in the division. So this 9 will give us 7 here. 7 into 5 will be 35. Okay, so the temperature will be 35 degrees Celsius. Okay, next one is part 4. If the temperature is 0 degrees Celsius, what is the temperature in Fahrenheit? And if the temperature is, it says, if the temperature is 0. Okay, if the temperature is 0 degrees Celsius, what is the temperature in the Fahrenheit? And if the temperature is 0 degree Fahrenheit, what is the temperature in Celsius? That means first you will put the value of C0, then you will find the corresponding value of, you will get the corresponding value of Fahrenheit, and then we'll put the F equal to 0, then we will get the corresponding value of degree Celsius. Okay, so we have this equation F equals to 9 by 5. I'm writing this equation again and again, that so that you can easily learn and remember this. Okay, this is a very important equation. So at temperature 0 degrees Celsius, okay, the F will be, Fahrenheit reading will be 9 by 5. At the place of C, we'll write 0 plus 32. So as this is multiplied by 0, so the whole term will become 0, so F will be equals to 32. So the temperature will be 32 degree Fahrenheit. Okay, and if temperature is 0 degree Fahrenheit, so what will be the Celsius reading? So that's again, we'll first write the equation, which is F equals to 9 by 5 into C plus 32. So now at the place of C, we'll write the 0 equals to 9 by 5 C plus 32. Okay, for this will be wait a moment. Okay, when you solve this, you will get C as, this 32 will be shifted to the other side, so this will be minus 32, and this 9 by 5 will become 5 by 9. Okay, when you solve it, you will get the answer as minus 17.8 Fahrenheit, not the Fahrenheit, as degree Celsius. Okay, this is minus 17.8 degrees Celsius. So now we come to the last part of this question. It says, is there a temperature which is numerically the same for the Fahrenheit and the Celsius? If yes, and find it. We have already done that, which is, if the Celsius temperature is minus 40, the Fahrenheit temperature will be also be minus 40. Okay, so solution I have shown it already above, so I'll write part 5 as, at 40 minus 40 degrees Celsius, the Fahrenheit temperature is also minus 40 degree Fahrenheit. Okay, its calculation I have shown above here. Okay, You can directly write it, or you can also show this calculation, this part. Okay, that's the end of the question number 8 of exercise 4.3, and so the exercise 4.3. okay, now we'll move to the another topic. We have equation of line parallel to the x-axis, which is a very small topic. Okay, so let's come to this topic here, equation of line parallel to the x-axis and y-axis. Based on this we have exercise 4.4. okay, so we'll first start with the example number 9, which says solve the equation 2x plus 1 equals to x plus 3. You are asked to solve the equation 2x plus 1 equals to x minus 3 and represent the solution first on the number line, then on the Cartesian plane. Okay, so simply the equation given to us is, we have 2x plus 1 equals to x minus 3. So first we have to solve this equation. So this will be 2x, this plus x will be shifted to the left hand side, so it will be minus x. On the other side we have minus 3, and this plus 1 will become minus 1 on the right hand side. So 2x minus x will result into x, and this minus 1 and minus 3 will result into minus 4. So that's the solution of this equation. Now we have to represent this equation on the first on the number line, then on the Cartesian plane. Okay, so we have x equals to minus 4, which means first we have to draw a number line, which you already know from your, we already did this in the chapter number 1. okay, so first draw a straight line, mark a midpoint, that will be its 0. okay, on the right hand side we have positive value, and the left hand side we have negative values. So let's mark the points. So we have 1 2 3 4 5 6. Okay, 6 here. Similarly we have 1 2 3 4 5 and 6. So let's write the numbers 1 2 3 4 5 6. Similarly minus 1 minus 2 minus 3 minus 4 minus 5 and minus 6 on the right hand side. On the left hand side we have negative value, and right hand side we have positive values. Okay, so the point that we have is x equals to minus 4, so that will be here. So this is a representation of this x equals to minus 4 on the number line, like you are asked here to represent this on the number line. So this is the representation of this same equation on the number line. So first you have to draw a number line, then we will locate the point, which is x equals to minus 4 is here. Okay, then we are also asked to represent this in the Cartesian plane. Okay, Cartesian plane, that means we have to draw the xy plane. Okay, on this one first draw the two axes, the vertical one, which is the y-axis, then we have the horizontal one, which is the x-axis. Okay, so equation that we have here is x equals to minus 4, but in order to represent this on the graph paper on the Cartesian plane, we need the value for x and the y coordinate, but we don't have a y coordinate here. So we'll assume this equation as let x plus, we add the y coordinate by with a coefficient 0, okay, equals to minus 4. Okay, we have converted this equation into the form of equation in two variable, with second variable y having a coefficient 0, because this 0 into y will result in 0, so we'll remain with again x equals to minus 4. Okay, so let's find its few solution. So let's take let y equal to 0, then what will the value of x? Value of x will be x plus, as we have y equal to 0, so its coefficient is already 0, y is we have taken as 0, so it equals to minus 4. That means x is equals to minus 4. Now let's take let y equals to 2. Now we have taken y equals to 2. That means then x plus coefficient is 0, at the place of y will write 2 equals to minus 4. This 2 into 0 will again 0, so we'll get x equals to minus 4 again. Okay, now let's take another solution. Let y equals to minus 3. Okay, then again we have x plus 0 into minus 3 equals to minus 4. This will result into again x equals to minus 4. So the solutions are we'll write x for x here and y here. On taking y 0, x is minus 4. On taking y 2, x is again minus 4. On taking y as minus 3, and x is again minus 4. So we'll represent these points on the graph paper. First solution is x. First mark the point let here. We have 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Minus 1 minus 2 minus 3 minus 4 minus 5 minus 6 minus 7. Similarly plus 1 here, plus 2 3 4 5 and 6. Similarly downward side, minus 1 minus 2 minus 3 minus 4 minus 5 minus 6 and minus 7. This is y bar, this is y here, we have x here and x bar here, and this is our origin. That's a Cartesian plane. So let's represent this point on the graph paper. We have x, y 0 and x minus 4. Y is 0 and x is minus 4 will be not here, it will be here. Next is y2 and x is again minus 4. Y plus 2 is here and x minus 4 is here. Next we have x minus 3 and y minus 4. Y minus 3 is here and x minus 4 is will be here. Okay, and you can see that when you plot this line, when you join these 2 points, you will get a line which is parallel to y-axis. Okay, you will find that this line is parallel to the y-axis, and this represent the x equals to minus 4. Okay, so if you draw a line which don't have a y variable, or if its y variable is having coefficient 0, that means the graph of that equation will be parallel to y-axis. Okay, similarly, if a equation does not have a x variable, that means if the coefficient of a x variable is 0, that means that time the graph of that linear equation will be parallel to x-axis. Okay, so that's the solution of example number 9. Now we move to the exercise 4.4, which have equation. Give the geometrical representation of y equals to 3 as an equation in 1 variable and 2 variable. Okay, so we have to give geometric representation. That means we have to represent this on the graph paper. So first we have, let's write is answer number 1. We have y equals to 3. Okay, and that means we can simply represent it on the number line. We have this number line here. Can you mark the point here, y equals to 3? These not will be the x and x. These will be the y here and y dash here. Okay, you can also you can easily mark this point here. We have y equals to 3, that point will be here. So this represent y equals to 3. Next you have to represent this in the equation in 2 variable. Okay, so let's write the equation. We have y equals to 3. This equation can be written as, we can write this as, we already have y equals to 3, will include the x variable with coefficient 0. That means now this has become an equation in 2 variable. Okay, now let's find its solution. Let x equal to 0, then we have x equal to 0 plus y equals to 3. This result into y equals to 3. Let's take another one. Let x equals to 1, then we have coefficient of x is 0. At the place of x will write 1. We have y equals to 3. This 0 into 1 will result into 0, so we'll remain with y equals to 3. Then we have let x equals to 2. In that case, then we have coefficient of x as 0. At the place of x will write 2 plus y equals to 3, result into y equals to 3 again, because this 0 into 2 will result into 0. So the solutions of the equation are we have x here and y here. At x equal to 0, y is 3. At x equals to 1, y is again 3. And also at x equals to 2, y is again 3. So now we have to represent these points on the Cartesian plane. Okay. First point that we have, x is 0 and y is 3. So that will be here. Next we have x1 and y3. So x1 is here, y3 will be here. Then we have x2 and y3. x2 is here, y3, that means this point will be here. And when you join these points, this time you will get a line parallel to x-axis. Okay, mark the arrows here and we'll write the equation of line, which is y equals to 3. So now you can clearly see that if there is no x variable, then the graph of that equation will be parallel to x-axis, and if there is no y variable in this case, then in that case the graph of that equation will be parallel to y-axis. Okay. Similarly, we have one more question from this exercise, which is give the geometrical representation of 2x plus 9 equal to 0 as an equation in one variable and equation in two variable. So let's start the solution. Equation given to us is here is 2x plus 9 equal to 0, or this will be 2x equals to minus 9, or x will be equals to minus 9 by 2. Okay, minus 9 by 2 numerically is equals to minus 4.5. Okay, so you can represent this in the one variable form, that means in the on the number line. So we have this number line here. The point that we got here is x equals to 4.5, so that will be somewhere here. This is x equals to minus 4.5. Okay, now again we have to represent this in two variable, that means on the Cartesian plane. So in that case we have the equation x equals to minus, or you can write this as the original equation, which is 2x plus 9 equal to 0. Okay, so write this equation can be written as, we will include the second variable, which is y, with the coefficient 0. That means 2x plus y with the coefficient 0 plus 9 equal to 0, or this can be also written as 2x plus 0 into y equals to minus 9. This plus 9 will become minus 9 here. Okay, now let's find its one or two solutions. Let's take let y equals to 0, then we have 2x, we have coefficient of y is 0. At the place of y will write 0 equals to 9, not 9, minus 9. So this will be 2x equals to minus 9, or x will be equals to minus 9 by 2. Okay, that's the one solution. Let's find another one. Let y equals to let's choose another value. Let's say y equals to 4. Then we'll have this 2x into 0 into 4 equals to minus 9, and this will implies that x is equals to again minus 9 by 2, and 9 by 2 is equals to 4.5. okay, so the solutions are on taking y0, x is minus 9 by 2, or you can write minus 4.5. okay, similarly on taking y as 4, x is again minus 4.5. let's represent this point on the graph paper. On y equal to 0, x is minus 4.5, so that will be here. okay, again at 4, x equals to 4, y is also again minus 4.5. so let's draw a line joining these 2 points. I have taken only 2 solutions for this line. You can find as many solutions you want to find. You will find all those points lying on this particular line, which represent x 2x plus 9 equals to 0. okay, so that's how you can represent any line or any equation on in one variable, or also in the 2 variable form on the graph paper. okay, I hope you understood this. We have done 3 questions of this type, 1 example and the 2 questions of the exercise 4.4. okay, so that's it from this exercise and this chapter. With this we have finished the exercise 4.4, and also we have finished the chapter number 4, which is linear equation in 2 variable. okay, so what you have to do is practice all the question multiple times, so that you will be understand them better and you can solve them easily. okay, all the questions that we have studied in this session are very important, especially the 3 questions that we did from the exercise 4.3. all 3 are very important. okay, so practice them very well. So that's all for today's class. Thanks for joining here.